Hello, good morning. Welcome to Frank's School, 36th day of the 6th year. First video. I'm going to go on with my discussion of water wheels, so this will be the second video in that series. I'll eventually make it a playlist. I'm sort of watching a cat here. It's going to help probably. I mentioned about it's a seasonal thing here. Well, I find that learning and teaching, and the two go right together. I mean, Frank's School is a place for me to teach, but it's a place for me to learn. The two go right together, at least currently. I am learning faster probably than I'm teaching. But anyway, it's by seasons, as I said. And you just don't, at least the way it's working for me, you just don't learn everything and then go on and learn everything else. It comes around. And I thought a little bit about language acquisition. When a baby learns language, they don't just all of a sudden get nouns and then get verbs. The whole thing kind of grows. So that's a little bit what I'm talking about with this season stuff. All right, wheel and bucket design. I don't know about going into that too much. For one thing, it wasn't a finished product. I mean, in a way, Pelton wheels, the impeller or whatever you call it, in a Pelton wheel was completed. I mean but the best way to design a bucket or a water wheel, the spoking of a water wheel, how deep should the buckets be? How wide should the water wheel be? How big the water wheel should be is determined by what's called the head. I should have written it down. The head, the amount of fall you've got. Anyway, one of my sources is a treatise on hydraulics. I've read this. Well, I can't say as I read it in huge detail because it's so technical. But let me at least show you the title page here if I can find it. It was copyrighted 1903. Here it is, 1903. But I think the information, a lot of it was actually written, at least about the water wheels, was written back in 1889. That was the first edition. And that's one of my sources. And in it, the man says that actually the shape of the buckets, the size of the buckets, etc., that's best done by experience. Even though it's so technical in so many ways, just like you'd expect an engineering treatise to be, when it comes to the shape and the size of the buckets. So I'm not going to deal with that. Not at this time anyway. Now, I think of there having been a sort of an arrested development with water wheels. They weren't finished developing, I don't think. It was stopped. And it was largely, I think, because of, the gasoline and diesel and steam engines, sure, but also electricity. Because the demands of electricity have to do with high speed. That's why a Pelton wheel or a turbine work better. Water wheels are, come on, cat, are just too slow to be applied very easily to electricity. And I think in a way that was a trap. Now we also got over those 100 years of the 1800s and through the 1900s as well, we got addicted to lots and lots of power, energy use, and so that was one of the things. But my point is the development can go on as we get over that addiction. It can go on, and there have been things that have changed. Sheet metal now is readily available, widely available, and it was never really completely used in water wheels. Maybe it shouldn't be, I don't know, but it's there. There are plastics which may or may not be useful. It's not yet determined. I'll show you later. I took some plastic pipe and ripped it so that they were half circles and tried to use them as buckets. I think that actually would work, but it didn't work in my first attempt. V-belts now exist, and V-belt pulleys. I'm not at all sure that they are as good as flat belts, But V-belt pulleys, rope can ride in a V-belt pulley. And as I also showed you, hydraulic, air hose, uh, air hose, pressure hose, that can also run in a V-belt, because now we're not talking about huge amounts of power. The biggest of the windmills in Europe, and water wheels too, really, generated maybe 10 horsepower, maybe 15, typically 5. So it's not a lot of horsepower. So, you know, we're living in surrounded by stuff that it would be so much easier for them to, so much less wear and tear when it's used like that. And we also are living among the remains of the Industrial Revolution. Now, some of these are really disappearing fast, like iron, malleable iron, as opposed to cast steel. It's still around in old farm machinery, and farm machinery parts, like a baler. Well, a baler is a newer thing, but farm machinery parts, they are full of machine parts that can be used for other things. Axles, bearings, flat belts. You can still get flat belts, but more importantly, the pulleys, flat belt pulleys. You can make them out of wood, but they're around. It's possible to get them. Wheels off old hay rakes and stuff. I mean, there you've got a hub and you've got your spokes, and when I go outside I'll show you how I've used some of them. So the remains are around. Now, an awful lot has been recycled. I think World War I and World War II in Europe, you know, so much of that iron and steel was just recycled for the war efforts, and a lot of the stuff just ended up disappearing. There's probably more here in the United States. I'm not sure about that, but in, for example, Germany. Car and bicycle parts, as an example. I mean, they're all around. Junkyards are full of them, but they can be used. Tires, rubber, complete with air. Air-filled tires on a rim. Yeah, that can be used in different ways. The tires, I'm talking about the rubber part too, but certainly the wheels. Gears, there's gearing. If you've got a pair of gears, one gear by itself doesn't do you much good, but if you've got a pair of gears, well, they can be used. Hubs, they're the trick. Well, they're a tricky part of a water wheel to build, but there's a lot of hubs around. The steel hubs of trucks and cars, now they're being steel, they're going to rust up faster than iron, but they would last for a very long time. Spokes, material for spokes. Not so obvious. Differentials in cars. Differentials that give you that 90 that you need. Or, as I showed elsewhere in a video, if you take the pinion gear out and lock them together, you've got an axle in bearings with two wheels on the side. So they're all over the place. I mean, you can get a differential at a junkyard for around $100, maybe less, I don't know. Transmissions, not as obviously useful, transmissions, but it depends. Like a transmission on a bicycle, at least to teach with, the way it can throw into all those different gears. Now that's chain driven, not belt driven, but that bicycle chains could be made very long. And one man on a bicycle, I think a man generates about 1/20th of a horsepower. That seems small, but I'd heard that once. It's not a lot of horsepower, so they might be a little bit light, but you can make small water wheels. Pistons and cylinders, they're all over the place, and what appealed to me about them is that mechanical power can go straight into heat if you use it to compress air. That's used for air conditioning in a different way. But if you ever pumped up a bicycle tire, you know that pump gets hot. Well, you can make heat straight from the water wheel by going straight from the mechanical power of a water wheel. You don't have to run through that electricity trap. I really think eventually they'll see the light, and solar energy, wind energy, water energy, they do not have to run through an electrical circuit. They can be used because they're that's the thing. they're decentralized. They are decentralized. And where you need the electricity is when you decide you're going to try to centralize all that energy into a power grid or whatever and distribute it that way. All right, well, maybe I've been a little bit rambling, but I'm going on. Two things I'm going to do still. Well, there'll be many more than one video, I suppose. Is I'm going to take you on a tour of Europe and stuff, and some of my books, and I'm going to go outside. All right, bye for now.